So we'll look at that. Well, here's Newton's first law. Every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. Well, what that really is saying, let's say you've got some type of object sitting here, and let's see if I can get my pen going. And we've got an object sitting there, and let's just say it's a rock or something that's sitting on the ground. Well, what it's saying, it wants to persist in its state of rest. Doesn't want to do anything. And kind of like a lot of us in the morning, we just want to stay in a state of rest, and we don't want to do anything, just kind of stay in bed. Well, what can happen though, it says it's compelled to change that state by forces impressed upon it. Let's say we're here and we start pushing on this rock. Well, this rock is going to move in this direction. So what we have here is a unbalanced force, or a force that is pushing on this rock. You see that quite often when you're running. We got some examples here of a rocket taking off, which you guys are going to do. Jet airplane, you're throwing a ball or any of that type of stuff. When you put a force on something, it is definitely going to move. Well, the other thing is, when you start thinking about a force, let's say if you toss a ball or something, and let's see if we can draw a basketball in here or a baseball. When you toss it and it's flying through the air, it really wants to go in a straight line. Now, and what it says is a straight line unless it's compelled to change that state by forces impressed upon it. And again, if you think about a ball flying through the air, there's a couple different forces acting on it. One is gravity. Gravity is pulling it down. So gravity is pulling it down. And the other one is friction. If you think of air friction, friction, air. If you've ever ridden a bicycle before, you've noticed the air kind of pushing against you. Well, that's slowing you down. If you've ever gone swimming, you can feel the water pushing against you. That is, friction. It is slowing you down. The other one, as we mentioned, is gravity. So gravity is pulling you down, and then friction is also working against you in the opposite direction, and it'll slow things down. When you launch our rockets, they're going to go up after a while, but eventually they're going to fall back to Earth because gravity is going to pull them down. And so when you start talking about Newton's first law of motion, or the law of inertia, and again, sometimes it's called inertia, and you're really looking at the forces that is acting upon an object. If the forces are balanced, let's say you're standing on a floor here, you're sitting in the classroom, and here's the floor, you're pushing down with a certain amount of force. And we'll get into how much that is a little bit later. But the floor is pushing back on you. Well, what that means is you're not moving. These are equal forces. If the forces are equal, there is no movement. It is when the forces are unbalanced or greater in one direction than the other that you're going to find movement. And so we'll look at that again a little bit later. We talk about Newton's second law. The other thing is things want to stay in a straight line. And again, we kind of related to that. Things will move in a straight line unless acted upon by something else. Gravity is one and friction is the other. When you talk about the Earth, gravity is the big overriding force. It's pulling you to the center. And we'll look at gravity in a little more detail there later. Friction always slows you down. You talk about aerodynamics. We'll look at aerodynamics in your rockets, fluid dynamics. Look at the shape of a submarine. All those things are there to reduce friction. So for Newton's first law, again, it's the law of inertia. And quite often you'll see that. And it's really, things don't want to change unless they're acted upon by an outside force. So Newton's first law of motion, and on the next video we'll take a look at the second law of motion.